Okay, in this lesson we're looking at challenge in mixed quadratics, and that is the advanced examples relating to solving quadratics. So I've set two lessons. One is simple approaches, and that's in that lesson 7a. So we're looking at applying null factor theorem, looking at factorizing quadratic trinomials, looking at solving in these scenarios. Here, the idea is the same, except there may be more complexity in the process to solve. So as I said in the previous lesson, it's all about the choices now. So you have the skills, maybe you need to practice them a little bit more, but we've introduced those and you've got all these choices. You can factorize by using common factors, you can use DOPS, you can use decomposition, and if it's equal to 0, you can apply these to apply null factor theorem to be able to solve for the variables. You could use quadratic formula, you can complete the square, you can isolate, and we've got all these quadratic skills that we focused on that you can use to solve in different scenarios. So in this lesson, the questions that we're looking at, the manipulation and the isolation, will be a little bit harder, but of course we'll start with a nice easy one. Okay, so in this first example, we're considering, I know that I cut off the actual question part, so we want to solve. This 2x squared takes 7. There's lots of different approaches. The easiest way would be just to isolate. So if we isolate, then that means we want to get x on its own. We can say that 2x squared is equal to 7. Divide by 2, so we get x squared is equal to 7 on 2. And to isolate x, we can square root, not forgetting that when we square root, we look at both the positive and the negative solution. So x is equal to plus or minus root 7 on root 2. Now, as we move on later, a better answer would be to rationalize the denominator, and that is we don't want a square root value on the bottom. So a nice way to finish this one off is to look at plus or minus square root of 7 over square root of 2. If we multiply by square root of 2 on top and bottom, then it does something nice there. Square root of 2 times square root of 2 is just 2. And square root of 7 times square root of 2 is square root of 14. So we end up with plus or minus square root of 14 on 2. We've done something nice. We got rid of that surd off the denominator. Now, at this stage, I'm happy with that answer. This is a better answer, so just keep that in mind. Now, the other option you could have taken with this particular question is you could have gone down the DOPS route. So, hopefully, if you wanted to take the DOPS route, 2 is a common factor, and you've got x squared takes 7 on 2 equal to 0. We can get rid of that 2 now. So we've got x squared takes 7 on 2 is equal to 0. To treat that 7 on 2 as if it's a square, we've got take root 7 squared on root 2, so the whole thing is squared, is equal to 0. And then we can set that up using DOPS. We've got x take square root of 7 on square root of 2, x plus square root of 7 on square root of 2 is equal to 0. And using null factor theorem, each of these brackets will be equal to 0. So we've got x is equal to root 7 on root 2, or x is equal to negative root 7 on root 2. So you can see that both answers are the same. Don't stress too much about the rationalization unless it's clicked for you. And a nice, simple solution either way. We can take the DOPS route, or I assume that most of you will take the isolation route. So the second example, we want to solve for the unknown. So the first thing we'll need to do is isolate. Now, the goal is we probably want to strategize by going isolate so that it equals 0. We then possibly hope to be able to factorize and then use null factor theorem. So that's the approach I'm going to take. I'll start by adding 2m squared to both sides. So now I've got 8 take 7m plus m squared is equal to m plus 2. I can now subtract m from both sides, so I've got 8 take 8m plus m squared is equal to 2. Now I can subtract 2 from both sides, and I've got 6 take 8m plus m squared is equal to 0. So I can rewrite that to make it look more like a quadratic. M squared take 8m plus 6 is equal to 0. We could possibly look at 2 options here, or 3 options. We could look at decomposition. We could complete the square, or we could use quadratic formula. Now, I'm going to say that decomposition isn't possible, because when we look at A, C, and B, we get A times C, which is 6, and B, which is negative 8. I can't think off the top of my head any factors of 6 which will add or subtract to give me negative 8. So I know straight away that's out. That's not possible. And it'll only complete the square or quadratic formula. I'm going to go down the quadratic formula route. I can look at my discriminant, and that's b squared, which is 8 squared, negative 4 times 1 times 6. And so I've got 48, take away 24, and I'm left with 24. So that kind of confirms what I thought. It's going to be an irrational answer there. So m will be equal to negative b plus or minus the square root of the discriminant on 2a. So negative b is negative 8, which is positive 8 plus or minus the square root of 24 on 2 times a, which is 2. And possibly we can see that this is root 4 times root 6, and that would make that 2 root 6. You don't have to go down that path. Again, that's a third skill that maybe not all of you have done. We've got m is equal to 8 plus or minus 2 root 6 on 2. Now, there's a common factor of 2 for all elements, so we can divide them all by 2, and we end up with m is equal to 4 plus or minus root 6. So there's our answer in its exact form. If you wanted to, you could split it and say m is 4 plus root 6, or m is 4 take root 6, but this is the same thing. I would accept both answers. Now, you should be able to get the same answer using completing the square, but I won't do that now. Okay, so you can see already that's a little bit more complex. There's more to it than just, oh, yep, I can solve this. So there's 2 examples. We've got 2 more to go. The third example, we're applying it into a situation. So here we have the base of a triangle. So let's draw a triangle. Is 3 more than twice its height. So let's say this is its height. We'll use h as our variable. So 3 more than twice its height makes the base 2h plus 3. And we all know that the area of a triangle is base by height on 2, or 1/2 base times height. Now I know, again, I cut off the question here. I want you to calculate the height of this triangle. So that means we have to formulate an equation here and then solve that equation. So we know that area is base times height on 2. We know that the area of the triangle is 115. So we've got 115. The base is 2h plus 3. The height is h, and we're all over 2 there. So we want to go through the process of isolating, and hopefully, if we do this right, it's probably going to end up as a quadratic equation. So if we multiply by 2, we get 230 is h multiplied by 2h plus 3. We can expand this out, and we get 230 is 2h squared plus 3h. And if we subtract 230 from both sides, we get what we wanted, and we've got a quadratic equation. Now again, I'm not too sure if this is going to factorize nicely. So if I look at A, C, and B, we've got 2 times negative 230, which is negative 460, and we're looking for 3. Off the top of my head, I don't know the factors of 460, so let's try a couple of things. 460 divided by 20. We accidentally got it on the first one. We've got 20 multiplied by 23. So if we make 20 negative, we've got negative 20 times 23, that's 460. And negative 20 plus 23 also gives us 3. So now we can factorize. Now, if you didn't see that, then possibly the best way to go about it is to use quadratic formula. Maybe it would be quicker. But in either case, we'll now go through this decomposition method. It's a non-monic, so we have to put in the extra steps. So 2h squared, take 20h plus 23h, subtract 230. Common factor of the first pair is 2h, and we're left with h take 10. And then 23 is a common factor of the second, and we've got h take 10 again. So we end up with 0 is h take 10, 2h plus 23. And we've got a null factor theorem scenario where we can isolate and work out the height. So h take 10 is 0, or 2h plus 23 is 0, and we get height is 10, or we can isolate this and we get h is negative 23 on 2. Now, this being an applied scenario, we can't have a negative height. That doesn't make sense. So this is not possible. And that means we've only got one answer, and that is that our height must be 10. Okay, so a bit of fun. Those ones where you have to formulate first, set up a scenario, take into account that there's information here. We can sketch out and we can create an equation to solve. Then they start to move into that more complex realm. The other side of the complex realm is questions like this, where we just start off with pretty complex algebraic expressions. Now, I'm hoping because you are looking at algebraic fractions in methods, straight away you can see the process here. So our lowest common multiple, our lowest common denominator, will be a product of 4x take 1 and 4x plus 1. So we want to do that for all three. So this first one will be 4x plus 1 over 4x take 1. We'll have to multiply by 4x plus 1 on top and bottom, and that becomes 4x plus 1 squared. Now we've got 4x take 1 on 4x plus 1. We'll have to multiply on top and bottom by 4x take 1 this time. So 4x take 1, and that will make that 4x take 1 squared. And finally with 7, we'll have to multiply by both to get it on that denominator. So multiply on the denominator by 4x plus 1 and 4x take 1, and the same on top, 4x plus 1, 4x take 1. And now we've got that common denominator across all three terms. Now we can get rid of it. We can multiply by that, and it has no effect. So that simplifies down nicely to 4x plus 1 squared take 4x take 1 squared is equal to 7 lots of 4x plus 1, 4x take 1. Now, I can see a different pattern, but I don't want to mess with your brains today, so I'm not going to go down that path. But we can go through this process of expand and simplify, and I think that'll be the easiest approach for us. So this being a perfect square, we're going to have square of the first, so that's 16x squared. 2 times a times b, so that means we've got 2 times 4x times 1, which will give us 8x plus 1 squared, and then we'll subtract this perfect square, which will be 16x squared take 8x plus 1. And on the other side, we've got 7 multiplied by difference of perfect squares, so that will be 16x squared take 1. All right, so let's make this a little bit prettier. 16x squared take 16x squared, that cancels. 1 take 1, that cancels. And we're left with 8x take negative 8x, so 8x plus 8x is 16x. And over here, we've got 7 lots of 16, which is 70 plus 42. And that's 112x squared, take away 7. All right, so now if we subtract 16x from both sides, we end up with a quadratic, 112x squared, take 16x, take 7 is equal to 0, and we've got something we can solve. So again, we've got a choice. Do we go down the quadratic formula approach? Do we go for decomposition? I'm going to try for decomposition, so A, C, and B. 7 times 112, and we've got 7, 8, 4, and we're looking for a difference of 16 between the values. Too big. Factors of 784 is a little bit challenging, so I'm going to scrap that, and I'm going to go down the path where we look at the quadratic formula. So discriminant, b squared negative 4ac. That means we're looking at 16 squared. Take away 4 times 112 times negative 7, which makes plus 3392. Now, it might be a bit of a big ask asking you to do that without a calculator. So these types of values won't really be in the tech-free exams. Now, the next step is that we're looking at calculating x. Now, x is equal to negative b plus or minus the square root of the discriminant on 2a. So we've got negative 16, which is 16 plus or minus the square root of 3392 on 2 times 112, which is 224. Now, we could go through the process of simplifying this down, but just getting this out, isolating, and simplifying down to there is good enough in my book at this stage. Okay, so being able to use that process of common denominators to get a quadratic to expand out and simplify into a form which we can solve or factorize depending on the approach that we take. Okay, so I'm hoping that all makes sense. These are obviously the more complex examples. If you found these too hard, then the idea should be that maybe you don't start with the advanced quadratic equation practice. You go back to the quadratic equation practice and work your way up. Okay, thank you very much.